Okay, so in the first entry in the table, you're looking for epsilon to be 4, which means you want to be within 4 units away. So what I'm going to do is I'm going to draw that envelope that we talked about, just see the boundaries, and I'm going to use a different color. Okay, so 4 away from 3. So here's the limit, the limiting value, and you want to be 4 away. And you can either be above, so this would be 7, or you could be 4 below, which would take you to -1. Okay, so this is for the first one. So remember, you're looking for the large n value so that if you pick any little n after that, you'll be within the envelope. So basically, this is right on the envelope, so that would be your large n value. So that's going to be for n being 2. Okay, so if you substitute 2 in here, you get 3 minus 4, which is -1. So remember that you want to find the n value so that right after that you make it inside the envelope. So this would be your n equals 2. So the next n value or anything after that will ensure that you're going to be within the envelope. So that should be 2. Now for the next one, you want to be within 3 units away. So I'm going to pick a different color. I'll use green here. And so I'm going to pause it. I'm just going to redraw the picture. So, okay, so for the next one, your epsilon is 3, which means that you want to be within 3 units away from the limiting value. So that means that you can either go up to 6 or you can go down to 0. So you're looking for the large n value so that if you pick anything after that, you'll be inside the envelope. So look what happens. So this is your n value. So this is going to be n equals 2. If I pick anything after n equals 2, so if I pick 3, 4, 5, 6, 7, I will be within this envelope no matter which number I pick. So my large n is going to be 2 as well. Okay? So then for the next one, you want to be within 2 units away from the limiting value. So now you're here. So, or here. And again, you're going to pick the large n value so that anything after that will put you inside the envelope. So it's going to be here. So here you're right on the border. So this is your n equals 4. So then if you pick anything after that, so any of these values right here, you'll be inside the envelope. So this will be 4. Okay, so I'm going to pause it again, erase some extra stuff so we can continue looking at the next problem. Alright, so then for epsilon being 1, we want to be 1 unit away from the limiting value. So I'm going to go up to 4, or I can go down to 2. And this is something I can actually clearly see from the picture, that at n equals, so 1, 2, 3, 4, 5, 6, 7, 8, at n equals 8, I'm right on the border, and I can confirm this with algebraically, right? So I can substitute n with an 8 and make sure that I'm actually on the border, and I am because it's equal to 2. So I'm right here. So that's going to be my large n value. So if the n is 8, I'm right on the border. So then if I pick anything after that, it's going to be it's going to put me inside the border. Because remember, the large n value that you're choosing is the number, so that if you pick anything after that number, so anything greater, you will be guaranteed to be inside the envelope. Okay, so the next one is a half, and this is the one where like it's harder to see. So what I would do is kind of looks like it's here, but I'm not quite sure. So I'm actually gonna think about, if I want to be half away from the limiting value of 3, then I'm looking for the answer to be 2.5, right? So when is that going to happen? So you algebraically solve it. I'm just Okay, so algebraically I get n to be 16, right? So if it's 16, I am going to be exactly at epsilon being half, but I don't want to be on the border, I want to be inside. So 16 is going to be the large n value. So it looks like it's here. So 8, 9, 10, 11, 12, 13, 14, 15, actually 16. So look what's going to happen. At 16, I'm exactly half away, but if you remember to look at the definition, you want the difference to be less than epsilon, so you want to be inside the envelope. You don't want to be in the border, you want to be inside. So for epsilon being a half, you're going to be right here. Right, so you're half away from the value, and then anything after that will put you inside the envelope. And then the last one is also going to be done algebraically because when you're getting to the really small epsilon number values, you really can't see from the picture clearly which n value it is. So this is where you either want to use the table on your calculator or you want to algebraically solve it. So I'm going to pause it and do the solution. Okay, so before I solve it, just to remind you, so if epsilon is 0.01, I'm looking for the answer to be 0.01 away. And as we can clearly see, it's going to be below. So I'm looking for the answer to be 2.99. So I'm going to set it equal to 3 minus 8n. And algebraically, I'm going to figure out for what n value that happens. Okay, so I get n to be exactly 800. And if it's exactly 800, that means I am right on the border. So if I substitute n with 800, I will be exactly 0.01 units away from the limited value. But I don't want to be exactly 0.01 away, I want to be actually closer. So that 800 is going to be the big N. So then if I pick anything after that, I'll be inside.